Hi students, good evening. So today, right, we are going to look at the session 11. So in Canada, we'll cover the capacitor circuits. So it's a very important topic. Okay. So capacitor circuit and another we are basically taking ஒரு capacitor இல்லாம we are trying to take what multiple number of capacitors. Okay. When you take multiple number of capacitors, we are going to arrange them in a circuit. Circuit and சொன்னா ஒண்ணும் இல்ல, like when you are keeping a voltage source, so every time you are using the capacitors to charge them, we will require what voltage source, right? So ஒரு voltage source இருக்கும், like it can be a cell or a battery. Remember, cell or a battery will represent like this. Okay. Then when we have the capacitors which are connected in a particular arrangement, so if they are connected in a set of manner, we will call it as a series. If they are connected in another set of manner, we will call it as parallel. So we will try to see what is series and what is parallel. Okay. So in the series and parallel concept, right, இது ஒரு capacitor மட்டும் கிடையாது. Even when we go to the current electricity chapter, right, அங்க we'll talk about the series parallel combination of resistors. Okay, அதுக்கப்புறம் when we go to the electromagnetic induction chapter, there we'll talk about inductor coil. There we'll talk about what inductor coil. Again, there also same concept will come, series and parallel arrangement. So what is this series arrangement or parallel arrangement? So these three are called as what? Generally we'll call them as the components of the electrical circuit and so on. What do you call them as? The capacitor, resistor and inductor. We call them as what? Component of the electrical circuit. Okay. There will be something else called as electronic circuit, like semiconductors and communication systems, right? Adala we'll talk about electronic circuits. Anganana we'll be using these diodes, transistors. That's why they are called as what? Electronic devices. Diodes and transistors, right? What do we call them as? Electronic devices. Okay, va? So here we'll start with the basic concept of what is a series and what is a parallel. இது ஒரு capacitor மட்டும் கிடையாது. This is the general definition. இங்க பாருங்க, you have a capacitor. So this is the voltage source. Generally in our circuits, there will be what? Voltage source, which can be a battery or a cell. So if you have a capacitor, இங்க ஒரு capacitor வச்சுக்கோங்க, with a capacitance C1. There is another capacitor C2. If one plate of this capacitor C1 is connected to the other plate of capacitor C2. So one plate of capacitor C1 is connected to the other plate of capacitor C2 without any junction or link in between. So nadula, we should not have in nadula, there should not be any junction or any link. Straight capacitor C1 order one plate is connected to the C2 order next plate. Okay. Appadi connection irundha, then what do we call it as? We will call it as what? Series arrangement. Adhe nama resistor case la paatha vechukonga. What is it? See, generally these capacitor, resistor, inductor, right, we will call them as two terminal device nu solluvom. Enadhi? Two terminal. Why two terminal? Because paranga, if you take capacitor, right, side 1, side 2. Terminal and sonna, what is it? The place where you can connect. So paranga, இந்த பக்கம் ஒரு கனெக்ஷன் நம்ம போடலாம், இந்த பக்கம் ஒரு கனெக்ஷன் போடலாம். அந்த மாதிரி ரெசிஸ்டரும் அப்படிதான். Terminal 1, terminal 2. Same with the inductor also. அங்க என்ன வரும்? Terminal 2 1 வரும், terminal 2. So these are called as what? two terminal devices. Okay, so இங்க பாருங்க, one terminal of the capacitor C1 is directly connected to other terminal of the capacitor C2. Okay, without any there should not be any junction or nothing should be there in between. Okay, அப்படி இருந்தா then that kind of an arrangement is called as what? Series arrangement. இங்க என்ன தெரியுமா, with regard to series arrangement பாருங்க, if you connect this side to that positive terminal of the battery, this side to the negative terminal, so once you connect it to the voltage source, right, என்ன ஆகும் பாருங்க, இந்த பக்கம் இருக்கிற plate, right, this will get what? Positive charge. ஏன்னா it is directly connected to the positive plate of the battery. அதோட வேல்யூ நீங்க Q ன்னு வெச்சுக்கோங்க. Because capacitor plates, they will have what? Equal and opposite charges, right? அதனால this plate will have to get minus Q. Second plate of the capacitor has to get minus Q. But எப்படி? How is it getting the minus Q charge? It is getting the minus Q charge from the neutral wire. பாருங்க, this plate is connected to the neutral wire, right? And the neutral wire லந்து it is getting a minus Q. But wire is neutral, so it will supply a plus Q to the plate of the capacitor 2. So in the baka it is getting minus Q, means other side has to give plus Q, so that totally the wire is what? Neutral. And a wire cannot get any charge, wire has to be neutral, right? Adanala if this side is giving minus Q, means and the baka it will be plus Q, so that the wire will be always neutral. Okay, so paranga, from the negative terminal of that voltage source, there will be negative charge, because capacitor plates, right, they should have equal and opposite charge. So this plate is having plus Q, means other plate will have what? Minus Q. Okay va? So this is what, so இப்படி நம்ம அசைன் பண்றது தெரியுமா, this is what we generally call as the charge assigning approach. என்ன சொல்லுவோம்? Charge assigning approach ன்னு சொல்லுவோம். Okay, so இங்க என்ன தெரியுமா, when you have two capacitors connected in series, the capacitors, right, will have same charge. Is an important point. When you have two capacitors connected in series, then the capacitors will have same charge. Two மட்டும் கிடையாது, even if you are having a 3 capacitors then வெச்சுக்கோங்க, all the 3 will have the same charge. If you are having 4 capacitors in series, all of them will have the same charge. Okay, so this is about the series combination. So series and sonodane, what is the thing? The one terminal of capacitor 1 is connected to the another terminal of the capacitor 2. Apdi. So if there is a third capacitor, means this will go on. Okay, so this arrangement is called as what? Series arrangement. But idhula enna, nadula you should not have any link or junction, that should not be there in between. Okay, if there is a link or junction, means we will not call as a series. Appo nama series nu solla mudiyadu. Okay, so series means what is the relation we have between the capacitors? The capacitors will be having the same charge. When you go to the current electricity chapter, right, angenana we will see that for resistors in series, right, we will have a different relation. For resistors in series we will have a different relation. Okay, angena theriyuma. So anyway we will see when we go there. Like paranga, idu or resistor R1 vechukonga, idu R2. If there is a current going through the R1, there should be no link, nothing should be there, right? Which means whatever the current going through R1, same current has to go through R2 also. And nadula there will be no junction or branch. So whatever the current going through R1, same current has to go through R2 also. So for resistors in series, right, resistors in series, and what is the condition? The current through them will be same. For resistance in series, the current through them will be same. Okay va? So idu patti again we will discuss it when we go to the resistors. Inga we are focusing only on what? Veru capacitors. Okay, ipo we look at what is this parallel arrangement. So parallel arrangement is sonna, you have a capacitor C1. Remember, capacitor is what? Two terminal device. Adu rendu terminals irukum. Same resistor appadida, inductor also same thing. Can you tell me what is a 3 terminal device? So you might have heard about a 3 terminal device. In electronic circuits, right, we'll talk about the 3 terminal devices. Okay, so transistor, right, will be a 3 terminal device. So when we go to the chapter, we will understand how do we design a transistor and how the transistor will have 3 terminals and how each of the terminals will be working. Okay, so paranga, we have a capacitor C1, 2 terminals are there, and another capacitor C2. This will also have 2 terminals. This can have 1 dash and 2 dash. If the terminal 1 of capacitor C1 is connected to the terminal 1 dash of capacitor C2, another terminal 2 of capacitor C1 is connected to the terminal 2 dash of capacitor C2. Appadi nama connect panna, this is generally called as what? Connecting across and solada. Enadi? Connecting across. Ippudi nama connect panna, what is it? The potential of the plate 1 will be equal to potential 1 dash. Appadidana directly connect panna by using a wire or something, right? A conducting wire you use to connect two objects means both objects will be at the same potential. In the concept I already discussed pannirukku. If you have 2 objects connected by a wire, conducting wire, the potential of both the objects will be what? Same dana. Similarly, paranga, 2 and 2 dash are connected, means potential of 2 is equal to potential of 2 dash, which means what? The potential difference across the C1 is equal to what? Potential difference across C2. So if we parallel arrange panna, what is it? If you have capacitors in parallel arrangement, what is it? We will see that the potential difference across the capacitors, will be same. Okay, va? So this is what is the idea of. So resistor case ne appadida. Resistor will have what? Potential difference across the resistor same. Inductor also same thing. When you have inductors in parallel, potential difference across the inductor will be what? Same. Okay, va? So this is about the parallel arrangement. So we have series arrangement and also we have what? Parallel arrangement. So now we look at the series arrangement particularly. We are having 2 capacitors C1 and C2 which are kept in series. Series and so the one plate of capacitor 1 is connected to other plate of capacitor. So in series, right, both the capacitors will have the same charge. In the point I'm already both the capacitors will be having what? Same charge. Look at this 2 capacitors, right, which are in series, they are connected to the voltage source. V is what? Voltage source or potential. V is what? Voltage source or potential. Okay, va? Here the capacitors are deriving charge from the cell or the battery. So where is the charge on the capacitor plates coming from? From the battery or the cell. Now in the capacitor circuits, right, they will be interested in knowing something called as equivalent capacitor. Equivalent capacitor enna theriyuma? Ipo namakitta ethani capacitors irukka circuit la? 2 capacitors irukka. Okay, if we replace both of them by a single capacitor, ipo namakitta irukka rendu capacitor nama ore capacitor vechi replace panna, what is going to happen paranga? You will have the source voltage V. In the rendu capacitor badala we will get what? Only one capacitor, and the capacitor capacitance value, right, we will be calling as what? Equivalent capacitance. Another generally we will represent this by what? C subscript EQ. Okay, what is this? Another equivalent capacitance. Correct? What is this equivalent capacitor concept? But we have 2 capacitors irukka, and the rendu nama ore capacitor vechi replace panna, that capacitor capacitance value is called as what? Equivalent capacitance. Inga enna theriyuma? This equivalent capacitor should do the same job as both these capacitors. இதுக்கு முன்னாடி என்ன இருக்கா, ரெண்டு capacitors இருக்கா. Whatever the circuit kulla, whatever the work they are doing, the equivalent capacitor should be doing the same job. What is the meaning of that? Paranga, these two capacitors, right, they are able to draw a charge Q from the cell or the battery. So the charge angle in the word, it is coming from the cell or the battery. So equivalent capacitor, right, should also draw the same charge Q. The equivalent capacitor also should also draw the same charge Q. Okay, wow. So this idea of simplifying the given set of capacitors by using a single capacitance, right, this is what we call as the equivalent capacitance. This is the basic meaning. We are trying to replace all these given capacitors by using just one single capacitor. This should do the same job as the original set of capacitors. Same job also in a series combination la, these two C1 and C2 are able to derive a charge Q from the cell. So the equivalent capacitor also should draw the same charge Q. Okay, wow. So we will try to understand what is the relation between this C equivalent to the value and C1 and C2. We will try to understand what relation between C equivalent value and C1 and C2. Paranga, the potential drop or potential difference across C1 evala, that is what we are representing by V1. So V1 is the what? Charge on this divided by adoda capacitance. Appadidana. Potential drop across C2 or potential difference across C2, adoda V2. That is what? Charge on this divided by adoda capacitance value. Okay. So ipo parunga, potential difference across C1 plus potential difference across C2. Adanadi the total potential difference, that is our voltage source or voltage value. So what you will have, V1 plus V2 is equal to V. V1 plus V2 value is V. So V1 plus V2 means what? Q by C1 varu plus Q by C2. Okay. So the equivalent capacitor case lo paranga, what we will have? Equivalent capacitor case lo we are having what? The equivalent capacitor is also having the same charge. Equivalent capacitor is also having the same charge. Okay. Capacitance evla C equivalent. Paranga, what is the potential difference across the capacitor? That value anna, that is equal to the potential of the voltage source. So what is the relation between the potential difference and the charge? Charge on this equivalent capacitor divided by adoda capacitance value. Charge on the equivalent capacitor divided by capacitance value. Okay. So that is the voltage of that source. So V க்கு பதிலா நம்ம இந்த வேல்யூ சப்ஸ்டிட்யூட் பண்ணலாம். Q by C equivalent. சப்ஸ்டிட்யூட் பண்ண என்ன வரும் பாருங்க, left hand sideலயும் இருக்கா, Q right hand sideல இருக்கா. அப்படியே கேன்சல் பண்ணா what will have? 1 by C1 plus 1 by C2 is equal to what? 1 by C equivalent. Relationship paranga, what is it? If we are having two capacitors in series and the rendu capacitors oda equivalent capacitance value evla, that will be given by what? 1 by C1 plus 1 by C2 is equal to what? 1 by C equivalent. Okay va? So enga theriyuma, the capacitors in series, each of them will have the same charge. Paranga, each of them will have the same charge and equivalent capacitance. Ipo nanda series combination nama ore capacitor vechi replace panna, that equivalent capacitance, right, will also have the same charge. Other relation, that is what? Relation between the series capacitors and other equivalent capacitance value. Okay, so what is it? 1 by C1 plus 1 by C2 is equal to what? 1 by C equivalent. Okay va? So this is the concept of equivalent capacitance for the series combination. Ingon enna theriyuma, when you are having the series combination of capacitors, what is the potential difference across the capacitor 1? V1 oda value enna? Q by C1. Potential difference across capacitor 2 evla? Q by C2. இங்க பாருங்க V1 is to V2, right, will be equal to what? Q by C1 is to Q by C2. Q cancel panna, what you will have? 1 by C1 is to 1 by C2. Okay, so this is what the ratio of the potential difference across the capacitors in series. But in the capacitor namakita series la irukku, then what is the ratio of the voltages across them? V1 is to V2 will be equal to what? 1 by C1 is to 1 by C2. Idu nama eppadi eludhala theriyuma? V1 is to V2, see, 1 by C1 divided by 1 by C2 means what? C2 அப்படியே numerator la போய்டும். That is what? C2 by C1. அப்படி நம்ம எழுதலாம். V1 by V2 value will be equal to what? C2 by C1. This is for two capacitors in series. But normally பாத்தீங்கன்னா we'll have what? Many number of capacitors. It is not like just we'll have only two, right? We can have sometimes many number of capacitors. If you're having many number of capacitors, right, அப்ப என்ன வரும் பாருங்க relation? The equivalent capacitance formula, right, will be similar. So you have three capacitors in series in vechkonga. What is it? 1 by C1 plus 1 by C2 plus 1 by C3. That will be equal to 1 by C equivalent. If you're having four of them, 1 by C1 plus 1 by C2 plus 1 by C3, that is equal to 1 by C equivalent. Okay. Adukapram what else we discussed? The potential difference across each of the capacitors. Ena series combination la irukra ella capacitors oda charge value will be same, but potential difference across them will be different. Adukku relation varum paarenga. V1 is to V2 is to V3 will be equal to what? 1 by C1 is to 1 by C2 is to 1 by C3. Appadidana. If you are having 4 nechkonga, what is it? 1 by C1 ni appadida is to 1 by C2, 1 by C3, 1 by C4. Okay va? That is what the ratio of the potential differences across each of the capacitors. Because while solving problems in series combination, right, these results we are going to use. Okay va? So this is about the series combination of the capacitors. Ingonu point anena, why are we keeping the capacitors in series? Nama capacitors oda idu series arrangement la vecha, what is the benefit? Benefit enna theriyuma? Na parunga, if you are having a capacitor which is connected across a cell or a battery, அப்படி நீங்க டைரக்டா கனெக்ட் பண்ணா what you are going to have in the steady state, right? Steady state means what? When the capacitor is fully charged, potential difference will be equal to what? Source voltage. Potential difference across the capacitor plate evala? Source voltage. If the source voltage is high in vechkonga, if the source voltage is high, appa enna agum? The potential difference across the capacitor plates also will be high. Remember, we have a relation between potential difference and the electric field. The region between the two plates will have what? Electric field. So the relation is what? The electric field strength will be V by D. V is what? The potential difference. V oda value jastiya irundha, field also will be higher. Appa enna agala theriyuma? If the field is very high, there can be a breakdown of the medium. Breakdown of the medium and sonna theriyuma? The medium in the place between the capacitor plates ade ionized. So ionizing means what? That is what we will call as what? The breakdown of the material. So when that happens, right, charge will flow. The positive plate la charge will flow to the negative plate. Okay. So there will be a danger of this breakdown of the medium or dielectric which is between the two plates. Once that is happening, right, and the capacitor, the property loosened, because capacitor is what? Charge storing device. Charge is leaking means all of that, the capacitor property itself is damaged. So one of the important things, and we will always have to make sure that the potential difference across the capacitor plates, the potential difference across the capacitor plates is less than breakdown voltage. Another, what is the exact name that you are using? Breakdown voltage and solvanga. What is breakdown voltage? The voltage at which the particles in the region between the two plates of the capacitor will get ionized. Okay, so what is the corresponding voltage called as breakdown voltage? Okay, wow. So always we should ensure that potential difference is less than the breakdown voltage. இப்போ பாருங்க, when you have a capacitor in hand, அப்படியே நீங்க டைரக்டா கனெக்ட் பண்ணா the source voltage will be equal to what? The potential difference across the capacitor plates, which can be sometimes high. அப்ப என்ன ஆகும்? The capacitor will be damaged. So நீங்க ஒரு high voltage source கூட கனெக்ட் பண்ணா what is going to happen? Capacitor will be damaged. அந்த situation prevent பண்றதுக்கு தான் we will use the series combination. பாருங்க, series combination என்ன ஆகும்? If you are connecting two capacitors in series combination, right? இங்க பாருங்க, what is the potential difference across C1 V1? Potential difference across C2 எவ்வளவு? V2. So what is the relation? V1 plus V2 is equal to V. So என்ன ஆயிட்டு இருக்கா? The potential difference on each of the capacitors, right, will not be equal to source potential. Okay, so V1 ரெண்டுத்தையும் நம்ம ஆட் பண்ணதா it will be equal to source potential. ரெண்டுத்தையும் நம்ம ஆட் பண்ணா it will be equal to what? Source potential. If you are having three capacitors in series ன்னு வெச்சுக்கோங்க, then what is going to happen? V1 plus V2 plus V3 is equal to V. Four capacitors ன்னு வெச்சுக்கோங்க, what you are going to have? V1 plus V2 plus V3 plus V4 is equal to V. So அப்ப என்ன ஆகும்? The potential difference across each capacitor, அதோட value will become lesser and lesser. Comparison to what? Comparison to source potential. Source potential கூட நீங்க compare பண்ணா the potential difference on each capacitor, the potential difference on each capacitor gets reduced in series combination. அதுல இருந்து நமக்கு benefit என்ன? We can prevent. What is the benefit from this? We can prevent the capacitor from getting damaged. Okay, wow. So we can prevent the capacitor from getting damaged. This is the purpose of keeping the capacitor in series. We can use the capacitors and make sure that they are not getting damaged. Okay, நீங்க அப்படியே எடுத்து voltage source கூட கனெக்ட் பண்ணா there is a chance that the capacitor might get damaged because of the high potential difference, where the medium between the two capacitor plates can get ionized. The potential where it gets ionized is called as what? Breakdown voltage ன்னு சொல்லுவாங்க. The potential where it gets ionized is called as what? Breakdown voltage. Okay, the electric field value where the medium gets ionized is called as what? Dielectric strength. Paranga, these two terms are important. One is what? Breakdown voltage. Breakdown voltage is for the voltage value where the ionization is happening. Dielectric strength, this is for what? The electric field value where the ionization is happening. Okay, va? So this is the reason why we will generally keep the capacitors in series combination. Okay, அடுத்தது பாருங்க, this is the kind of questions we will have on series combination. இங்க என்னது? They are giving two capacitors which are in series. இங்க பாருங்க, 2 microfarad கொடுத்திருக்காங்க, 3 microfarad. They are kept in series with the 100 volt. What is that? This is what? Source. Okay, find equivalent capacitance. நீங்க ட்ரை பண்ணலாம் அப்படியே. So என்னது? There is a 2 microfarad, 3 microfarad. Equivalent capacitance எப்படி வரும்? 1 by C equivalent is equal to 1 by C1 plus 1 by C2. அதுதானா? இங்க பாருங்க, இங்க நீங்க LCM எடுத்தா it will be what? C1 plus C2 by C1 C2. Reciprocate பண்ணா what you will have? C equivalent value is equal to what? C1 C2 by C1 plus C2. இந்த formula நீங்க ஞாபகம் வச்சுக்கலாம். If you are having வெறும் 2 capacitors in series, what is the equivalent capacitance oda formula? C1 C2 by C1 plus C2. Okay, original relation என்னது? 1 by C equivalent is equal to 1 by C1 plus 1 by C2. அதுல இருந்து we can get this. இது என்னது? ready-made formula types. We can use it only for what? 2 capacitors in series. பாருங்க, C1, இது C1 நம்ம எடுத்துக்கலாம். C2, C1 C2 means what? 2 into 3 by C1 plus C2. அதே விட 2 plus 3. What is it? 2 into 3 means what? 6. 6 by 5 microfarad. Yeah, C1, C2 both are in terms of what? Microfarad. So C equivalent also will be in microfarad. C equivalent also will be in microfarad. We should get it as what? So first answer, what is it? C equivalent value of 6 by 5 microfarad. Okay, what is the next part? They are asking what is the charge stored in each of these capacitors. Remember what we discussed? இப்போ நம்ம இந்த ரெண்டு கெபாசிட்டர் அப்படியே ரீப்ளேஸ் பண்ண வெச்சுக்கோங்க by using the C equivalent. நம்ம அந்த C equivalent வச்சு ரீப்ளேஸ் பண்ணா what is the C equivalent value? 6 by 5 microfarad. Voltage source எவ்வளவு? 100 volt. The charge on equivalent capacitor. இப்போ நம்ம ஒரு series combinationல we replace the given capacitors by using the equivalent capacitor. அப்போ என்ன relation? What is the relation between the இங்க இருக்கிற original capacitors க்கும் equivalent capacitor நடுவுல what is the relation? The charge on these original capacitors will be equal to the charge on the equivalent capacitor. அதுதானா? So we will try to find charge on the equivalent capacitor. பாருங்க, what is the potential difference across the equivalent capacitor? It is connected to the battery அப்படியே. Means what? The potential difference is what? 100 volt. Okay va? What is the capacitance of the value? 6 by 5 microfarad. So namakku enna venum? Charge dana. What is charge? Charge is equal to what? C into V, which is 6 by 5 microfarad into 100 volt. So what we'll get? 5 ones are 5 20s. So 120 microfarad into volt. இது எவ்வளவு தெரியுமா? மைக்ரோ அப்படியே இருக்கும், farad into volt எவ்வளவு? கூலும். So what we'll get? 120 microcoulomb ஆயிடும். So what is the charge stored on that equivalent capacitor? 120 microcoulombs. Remember, for a series combination, each of these capacitors will have the same charge. So charge stored in each capacitor will be what? Each of them will have the same charge, which is equal to charge on that equivalent capacitor. Adha value evala 120 microcoulombs varum. What is the value of that equivalent charge evala? 120 microcoulombs. Okay va? So this is the charge on both of them. In a series combination la both of them will have the same charge. அதுக்கப்புறம் என்ன கேக்குறாங்க? What they are asking? The potential difference across each capacitor. So பாருங்க, what is the thing that we discussed? V1 by V2 is equal to C2 by C1. ஞாபகம் இருக்கா? In series combination இதோட potential difference V1 வெச்சுக்கோங்க, இதோட potential difference V2. V1 by V2 will be equal to what? Actually what is the relation? V1 is to V2 will be equal to what? 1 by C1 is to 1 by C2. Okay, so நீங்க simplify பண்ணா what you will get? V1 by V2 will be equal to what? C2 by C1. இங்க பாருங்க, V1 by V2 is equal to C2 எவ்வளவு? 3. C1 is what? 2. Okay வா? So பாருங்க, V1 is equal to 3 by 2 into V2. இது நம்ம equation 1 வெச்சுக்கலாம். V1 is equal to what? 3 by 2 into V2. Okay, then V1 plus V2 is equal to what? 100 volt தானா? V1 plus V2 எவ்வளவு? 100 volt. இப்ப பாருங்க, V2 plus V1 பதிலா நம்ம என்ன எழுதலாம்? 3 by 2 V2 is equal to 100. Okay, so இது என்னது? V2 நீங்க காமன் எடுத்தா 1 plus 3 by 2 எவ்வளவு? 5 by 2 is equal to 100 volt. So இங்கல என்ன வரும்? V2 value வரும். What is V2? 100 volt into 2 by 5, that is 40 volt. So V2 oda value enna? This is 40 volt. V1 plus V2 எவ்வளோ 100, right? Which means V1 will be what? 60 volt பாருங்க. V2 எவ்வளோ 40 volt. V1 will be what? 60 volt. Okay. So இப்படி நம்ம பண்ணலாம். Or otherwise இங்க ஒரு ப்ரொசீஜர் என்ன தெரியுமா? ஆல்ரெடி நம்ம கிட்ட என்ன இருக்கா? We got the charge. We got the charge on both the capacitors, right? ஆல்ரெடி நம்ம கிட்ட என்ன இருக்கு? Charge values இருக்கா? What is the charge on each capacitor? 120 microcoulombs, right? What is charge on each capacitor? 120 microcoulombs, right? இங்க பாருங்க. This is charge on both the capacitors. And both are series, right? They'll have the same charge. இங்க பாருங்க, V1 will be equal to what? Charge by அதோட capacitance. Charge எவ்வளோ? 120 microcoulombs divided by capacitance என்னது? 2 microfarad. Micro cancel ஆயிடும். What is it? 60 coulomb divided by farad will be what? Volt. அவ்வளவுதான். That is V1. அந்த மாதிரி V2 எப்படி வரும் பாருங்க. ஆல்ரெடி நம்ம கிட்ட சார்ஜ் இருக்கா? Charge is what? 120 microcoulombs. ஏன்னா ரெண்டுத்துக்கு மேல we'll have the same charge because they are in series. Divide by what is the capacitance of the value? 3 microfarad, right? இங்கே அப்படிதான் micro cancel ஆயிடும். So what is 120 by 3 means 40 volt. Okay. So this is how we can calculate the equivalent capacitance, the charge stored and potential difference. Okay. Good, Maithili. So in the மாதிரி questions தான் வரும். So if you are having the series combination of the capacitors, இதில் என்ன தெரியுமா? So if we are given the series combination of capacitors, அதில் அவங்களை என்னென்ன கேட்கலாம்? They can ask us equivalent capacitance of the value. They can ask us charge stored on each of the capacitors. அந்த மாதிரி they can also ask us what? The potential difference across each capacitor. Okay, wow. So these are the things that can be asked. So this is about the series combination. Other than capacitors which are kept in parallel. Think about capacitor 1 and capacitor 2. எப்படி? Terminal 1, terminal 1 dash, 2 and 2 dash. They are என்ன சொல்லலாம்? Connected across. எப்படி இருக்கா? They are connected across each other. Okay, வா? இப்படி நம்ம கனெக்ட் பண்ணா what is the thing we are saying? The potential difference across each capacitor will be same. Okay, wow. The potential difference across each capacitor will be what? Same. இங்க பாருங்க, we are connecting this parallel combination of capacitors to a voltage source. என்ன பண்ணிட்டு இருக்கோம்? We are connecting the parallel combination of capacitors to a voltage source. So this is the source voltage. Okay. So இங்க பாருங்க, the capacitor 1 plate will get some charge from the battery or the cell. அதோட value Q1 வெச்சுக்கோங்க. Capacitor 2 will get a charge. அதோட value என்னது? Q2. Okay. What is common for both of them? Potential difference. இங்க பாருங்க, each of them is connected across the cell, which means what? Potential difference across capacitor 1, V1. Other value will be what? Source potential. Potential difference across the capacitor 2, that is also equal to what? Source potential. Why? Because both capacitor 1 and capacitor 2 are kept in parallel to the source. Like this. We have a source. Okay. We are keeping the two capacitors in parallel. Okay, wow. So this is the cell or the battery. Okay. Whatever the cell potential will be equal to what? Potential difference across capacitor 1 and the potential difference across capacitor 2. Okay. Now பாருங்க, we want to replace both the capacitors by one single capacitor வெச்சுக்கோங்க. That is what is the concept of the equivalent capacitance. அதுதான் equivalent capacitance ஓட concept. So we are trying to replace both of them by using a ஒரே capacitor வெச்சு நம்ம replace பண்ணா what you will be having? இங்க பாருங்க, this is our equivalent capacitor. அதோட capacitance value எவ்வளவு? C equivalent ன்னு சொல்லலாம். So this is connected across that voltage source. What is the charge that is taken from the battery? Capacitor 1 is taking a charge Q1, capacitor 2 is taking a charge Q2. So total charge எவ்வளவு? பாருங்க, total charge taken from the battery or the voltage source. Other value another Q1 plus Q2. Total charge taken from the battery or the voltage source Q1 plus Q2. Okay. Now what is Q1? C1 into potential difference across the capacitor 1. That is the source voltage. Q2 that is capacitance into potential difference across capacitor 2. That is the same source voltage. So Q1 plus Q2 is equal to what? C1 into V plus C2 into V. V common what is it? C1 plus C2 into V. So Q1 plus Q2 it will be what? C1 plus C2 into V. What is the idea of the equivalent capacitor? The equivalent capacitor idea it should do the same job as the combination. இப்போ நம்ம எந்த காம்பினேஷனோட இது நம்ம ரீப்ளேஸ் பண்ண போறோம், the job of this combination should be done by this single capacitor, அதுதானா? Which means the equivalent capacitor should draw the same charge. Draw on சொன்னது அந்த பேட்டரியில இருந்து draw பண்ண மாதிரி. The equivalent capacitor should draw the same charge from எங்கல இருந்து? From the battery or the source. Source ல இருந்து it should draw the same charge. Same charge என்னது? அந்த Q1 plus Q2. So இங்க பாருங்க, this equivalent capacitor is just connected to the voltage source. So what is the charge on this? இதுக்கு மேல charge எவ்வளவு வரும்? C equivalent value into the potential difference, which is V. Okay va? So this charge value must be equal to what? Q1 plus Q2. அப்போதானா நம்ம இந்த equivalent capacitance சொல்ல முடியும். So பாருங்க, C equivalent into V is equal to what? C1 plus C2 into V. VV அப்படியே cancel ஆயிடும். What we'll get? C equivalent is equal to what? C1 plus C2. So what is it? If you are having two capacitors in parallel, two capacitors parallel in then the equivalent capacitance of them, it will be what? C equivalent is given by what? C1 plus C2. If you have 3, what is the relation? C equivalent will be equal to what? C1 plus C2 plus C3. 4 in the C equivalent is equal to what? C1 plus C2 plus C3 plus C4. Okay. So this is how we will find the equivalent capacitance value of the parallel combination of capacitors. Okay. If you are having parallel combination of capacitors, each capacitor will have same potential difference, which is equal to potential difference of the equivalent capacitor. So remember, the equivalent capacitor மேல எவ்வளவு இருக்க potential difference? Same தானா? Source voltage. So each capacitor, the parallel combination, each capacitor will have the same potential difference, which is equal to the potential difference of that equivalent capacitor. And the equivalent capacitor potential difference. Okay va? Series point. What is the point? In series combination, each capacitor will have the same charge, which is equal to charge on that equivalent capacitor. Angana the relation in terms of the charges. Ingana relation in terms of the potential difference. Okay va? When you look at the charge values, so Q1 is to Q2, Q1 is to Q2 will be what? Q1 is C1 into V. Q2 is equal to what? C2 into V. So C1 into V is to C2 into V. V cancel it. What is it? C1 is to C2. So in parallel combination of capacitors, the ratio of the charges on them will be equal to what? The ratio of the capacitors. If three capacitor namakku series parallel enna vechukonga, then what we will have? The ratio of the charges on them will be what? Apdiye C1 is to C2 is to C3. So we are talking about ratio of the charges. அந்த கேஸ்ல என்ன, in case of the series combination we talked about the ratio of the potential differences. Okay, so we'll just try to summarize. பாருங்க, you have இங்க என்னது series combination, நம்ம parallel combination வச்சுக்கலாம். Okay, so series means what, C1 C2 like this. இப்படி கனெக்ட் பண்ணா what is it, series. C equivalent எப்படி வரும், 1 by C equivalent is equal to 1 by C1 plus 1 by C2. Okay, அதுக்கப்புறம் the ratio of the potential difference on them is important. V1 is to V2 will be equal to what, 1 by C1 is to 1 by C2. Okay va, so this is the two important relations. அதுக்கப்புறம் parallel caseல என்ன, the capacitors are connected across இப்படி C1 C2 இதனது source. C equivalent எவ்வளவு, C1 plus C2. ratio of the, இங்க பாருங்க, this will have a charge Q1, this will have a charge Q2. ratio of their charges எவ்வளவு, Q1 is to Q2 will be what, C1 is to C2. இந்த relation நமக்கு ஞாபகம் இருக்கணும். ஓகேவா, so this is what is the discussion about the series and parallel. okay, see இப்போ பாருங்க, ஒரு set of capacitors எடுத்துட்டு நம்ம parallel combination பண்ணா what we are going to achieve. ஏன் நம்ம parallel combination arrange பண்ணணும், parallel combination arrange பண்ணா remember C equivalent value, right, we are going to get a very large value for the C equivalent. So parallel combination நம்ம arrange பண்ணா what is the C equivalent value, C1 plus C2 அப்படி போயிட்டே இருக்கும். we are having 3 capacitors means C1 plus C2 plus C3 வரும். 4 capacitors means C1 plus C2 plus C3 plus C4. so by using a parallel combination of capacitors we can achieve, என்ன நம்மளால achieve பண்ண முடியும், we can achieve very high capacitance value. already ஏன் நம்ம series combinationல நம்ம ஒரு சில situationsல we will use the series combination. எதுக்கு, because if you want to prevent the capacitor from getting damaged, அப்ப என்னது, we will try to keep the capacitance in series. okay, if you want to achieve a very high capacitance value, அப்ப நம்ம என்ன பண்ணணும், we should keep the capacitors in parallel. okay va, so this is the purpose of arranging the capacitors in parallel. parallel arrange பண்ணா we will be able to get what, very high value for the equivalent capacitance. இங்க பாருங்க, this is a sample kind of question. in this parallel arrangement இங்க பாருங்க, so there are these 3 capacitors 1 2 3. எப்படி, how they are connected, so terminal, all these terminals are connected, all the second terminals are connected. so this is what idanadi enna solla, this is the parallel arrangement and they are connected in parallel to the voltage source. what is the source voltage, 100 volt. first and they are asking us what is the equivalent capacitance எவ்வளவுன்னு கேக்குறாங்க. what is the equivalent capacitance formula, straight right, for a parallel what is the formula, C equivalent is equal to C1 plus C2 plus C3 அவ்வளவுதான். so what is it, 1 plus 2 plus 3, 6 microfarad over. so equivalent capacitance எவ்வளவு, 6 microfarad. அதுக்கப்புறம் charge stored in each capacitor எவ்வளவுன்னு கேக்குறாங்க. பாருங்க, each of these capacitors எப்படி நம்ம அந்த capacitors arrange பண்ணது, we are keeping them in parallel to the voltage source. so potential difference across 1 microfarad அது எவ்வளவு தெரியுமா, that will be equal to the source voltage. so Q1 value எவ்வளவு வரும், C1 1 microfarad into source voltage. so இதானது, this is what, 100 microcoulombs. potential difference across 2 microfarad எவ்வளவு, அது same தானா, because that is also connected across that source. so அதுக்கு மேல இருக்கிற சார்ஜ் என்ன, அதோட capacitance value into potential difference, இது என்ன வரும், 200 microcoulombs வரும். அந்த மாதிரி இங்க பாருங்க, the third capacitor, what is the potential difference across the 3 microfarad capacitor ఇది 100 volt dana, because that is also connected parallel across the battery. So what is the charge on that? Adoda capacitance into potential difference idanadi 300 microcoulombs varo paranga. So equivalent capacitance value evla 6 microfarad. Apram what is the good? Okay, good Maitri. So apram what is the other one? The charge on each of them evaladi? Each of them will have a charge of paranga 1 microfarad mele evla charge 100 microcoulombs varum. 2 microfarad mele charge evla 200 microcoulombs. Q3 what is the charge? 300 microcoulombs. Okay va? See, ஒரு சில கேஸ் என்ன தெரியுமா, we will not be able to straight away tell. டக்குன்னு பார்த்தா we may not be able to say whether this is a series or parallel சொல்லிட்டு. இங்க பாருங்க, in the circuit shown in the figure, C ஓட வேல்யூ கொடுத்திருக்காங்க. what is C value? 6 microfarad. இங்க பாருங்க, they are giving us two capacitors. ஒரு கெபாசிட்டரோட கெபாசிட்டன்ஸ் எவ்வளவு C, இன்னொரு கெபாசிட்டரோட கெபாசிட்டன்ஸ் எவ்வளவு 2C. ஓகேவா? so which means இதோட வேல்யூ என்ன? 6 microfarad. இதோட வேல்யூ 2 into 6 means what? 12 microfarad. ஓகேவா? The charge stored in the capacitor of the capacity C is how much? என்ன கேக்குறாங்க? they are asking what is the charge stored in the capacitor C. இப்போ பாத்தீங்கன்னா we are not able to see whether they are in series or parallel. But என்ன தெரியுமா, observe this carefully. இதனது this is we generally call it as what? Negative terminal. அப்படிதானா? we will call it as what? Negative terminal of that cell or battery. இப்படி நீங்க represent பண்ணா what is it? This is what we call as earthing and சொல்லுவோம், connecting to earth. இந்த பக்கம் பாருங்க, இந்த பக்கம் வந்துதானா, which means what? both are connected to the earth. which means what? both are connected to the earth. both are connected to earth means நம்ம இப்படி represent பண்ணலாமா பாருங்க, because both are connected to earth. இதனது 6 microfarad, இது எவ்வளவு? 12 microfarad. both are connected to same thing, right? this is the earth. இது earth point வெச்சுக்கோங்க. so அந்த பக்கத்துல இருந்து இந்த பக்கத்துல இருந்து அப்படியே எடுத்துட்டு வந்துட்டு we can just join them. இப்போ நீங்க பாருங்க, what is it? this is what? C, this is 2C. எப்படி இருக்கு? how they are connected? சொல்லுங்க, how they are connected? they are connected in series தானா? they are connected in series with a 10 volt source. see, டக்குன்னு பார்த்தா we are not able to probably tell whether they are in series arrangement or parallel arrangement. but if you observe for some time, right, பாருங்க அந்த பக்கம் என்னது? that is connected to earth. இந்த சைடுல அப்படிதானா? this side also it is connected to earth, which means what? நீங்க அப்படியே அந்த ரெண்டு சைடு ஜாயின் பண்ணா both are connected to earth, right? which means what? you will see that the C and 2C they are forming what? a series combination மாதிரி. they are forming what? series combination. okay, so what is their equivalent capacitance value? series combination and what is the equivalent capacitance? remember we discussed about this formula, right? what is it? C1 C2 by C1 plus C2. if two capacitors are in series, அதோட equivalent capacitance value எவ்வளவு? C1 C2 by C1 plus C2. actual relation என்ன? 1 by C equivalent is equal to 1 by C1 plus 1 by C2. இதுதான் actual relation. but நீங்க simplify பண்ணா அப்படி வரும். okay, பாருங்க, what is it? 6 into 12 by என்னது? 6 plus 12. எவ்வளவு? 6 into 12 by 6 plus 12. ஓகேவா? 72. 6 12 72 divided by 18. so 4 microfarad வருது. so அந்த series combination ஓட equivalent capacitance எவ்வளவு? 4 microfarad. பாருங்க, which means what? நாம அந்த ரெண்டு கெபாசிட்டரோட இது நம்ம ரீப்ளேஸ் பண்ணலாம் by using a single capacitance. அதோட வேல்யூ என்ன? இந்த 4 microfarad வச்சு நம்ம ரீப்ளேஸ் பண்ணலாம். அப்படி ரீப்ளேஸ் பண்ணா பாருங்க, what will be the charge on equivalent capacitor? அந்த equivalent capacitor மேல எவ்வளவு சார்ஜ் வரும்? அதோட capacitance 4 microfarad connected to that source 10 volt. So what is the charge capacitance into potential difference தானா? So capacitance எவ்வளோ? 4 microfarad into 10 volt. So என்னது பாருங்க, 40 microcoulombs. So remember the point, in a series combination, நம்ம series combination எடுத்தா the capacitors in series combination will have the same charge, as the equivalent capacitor. The capacitor series will have the same charge as the equivalent capacitor. So apna, what is it that they are asking? They are asking what is the charge on the capacitor C. adana avanga enna kekranga, what they are asking, charge on the capacitor C. The capacitor C mattum kediyadu, both of them will have the same charge. C ku mele adhe charge da, 2C ku mele adhe charge da. What is it? 40 microcoulombs, because they are in series combination, they both will have the same charge. Okay va? So in the question paranga, like this also we can have some questions relating both series arrangement and parallel arrangement. Paranga, the capacities of three capacitors are in the ratio 1:2:3. Okay, their equivalent capacity when connected in parallel is 60/11 microfarad more than when they are connected in series. Inga paranga, so they are giving us a ratio of three capacitors, other values, actual values nama kudukala. In fact, they are asking what the individual capacitors adoda capacity values kekranga, which means they are in fact asking what are those values of these capacitances. Eppadi and the relation nama find out pandrathu paranga, they are giving us what the ratio of their capacitances 1:2:3 and kuduthirukanga, which means we can say one of them is having a capacitance C, other is having a capacity 2C, third is having a capacity 3C. Appadi nama arrange pannalam. So if they are kept in parallel means what? Parallel pota, what is it? C equivalent evla? Parallel means what? C equivalent formula is what? C equivalent is equal to C1 plus C2 plus C3 dana. What is it? C plus 2C plus 3C. Evladhe? 6C varum. That is the equivalent capacitance of the value when they are in parallel. If you are keeping them in series in vechukonga, then what is the formula? 1 by C equivalent is equal to what? 1 by C1 plus 1 by C2 plus 1 by C3. What you have? LCM is 6C. So 6 varum, 3 varum, 2 varum. What is it? 11 by 6C. This is what? 1 by C equivalent. So we will get for a series, what is the C equivalent value? 6C by 11. 1 by C equivalent 11 by 6C. What is the C equivalent value? 6C by 11 varum. Okay. So in question statement, what is it that they are saying? The what they are saying? The equivalent capacity when they are connected in parallel is 60/11 microfarad more than when they are connected in series. Means what? The parallel equivalent capacitance 6C is what? 60/11 microfarad more than the series. Means series value evla? 6C/11. adukku nama 60/11 microfarad add panna, we will get what? Parallel. So the parallel equivalent capacitance is 60/11 microfarad more than the series. Is the relation. Series arrangement la nama kitta irukra what is the equivalent capacitance of the formula? 6C/11. adana. So the parallel equivalent capacitance of the value, which is 6C, that is what? 60/11 microfarad more than the series equivalent capacitance of the value. inga parunga, ipo C is a variable dana, idu nama appadiye left side eduthu polam. So 6C minus 6C/11, that is equal to what? 60 by 11 microfarad. Okay, so இங்க LCM எடுத்து பாருங்க, what is it? LCM எடுத்தா என்ன வரும்? 66C minus 6C by 11 வரும். What is it? 60C by 11. That is equal to what? 60 by 11 microfarad. இங்க பாருங்க, 60 cancel ஆயிடும், 11 cancel ஆயிடும். What is the C value? 1 microfarad வரும். So C எவ்வளவு வருது? 1 microfarad. Means what is the capacitance value which we are taking initially? C, 2C and 3C தானா? Which means what? C value எவ்வளவு வருது? 1 microfarad, which means the 3 capacitors are what? The 3 capacitors are what? What are those? 1 microfarad C. 2C means 2 microfarad. 3C means what? 3 microfarad. அவ்வளவுதான். So what is the answer for this? Another option B. So what is the individual capacitors or capacitance values are what? 1 microfarad, 2 microfarad and then 3 microfarad. Okay va? So this is it guys. Idoda we will try to stop it today and we will continue our discussion in the next class. And in the topic நம்ம கொஞ்சம் டீடைலா போறோம், because this is very important for the NEET examination la mostly rail on capacitors. They will try to give majority of the times this the series, parallel or the capacitor circuit based on the question or maximum. So we will try to spend some time on it. Okay va? So far what we covered, we have covered the series combination and then parallel combination. Okay, so அடுத்த session we will try to see what are the different ways of having the capacitor circuits. ஏன்னா இந்த நம்ம இப்போ பார்க்கறது என்ன தெரியுமா, series and parallel is a very simple arrangement. இதுல இருந்து we can try to build some complicated circuits. அது எப்படி வருதுன்னு சொல்லிட்டு we will try to look at it. Okay va? So we will continue in the next class.